Okay, so I figured it out. What you guys can do, okay, is there should be a second function. In my case, it's a shift, and you can watch what happens with these keys here in particular. What you're going to see is as soon as I click that, they have that -1 that I was telling you about. Okay, so this is the inverse. And what that means, if you remember from our exponential unit, is it just means this: 1 over cosine, 1 over sine, because the exponent on it is to the -1, so it goes to the denominator. That's just a little bit of understanding, okay? Not that you're not gonna use that. All you need to know is how to type it in your calculator to get the angle, okay? What you're gonna see here is, what's interesting is 0.6. Now if I do this, I've hit shift, right? So it's got the -1. If I go 0.6 sine inverse, because that's the trig ratio that I'm using, should get 36. We'll call it 30. Well, you could see that's 36.86 or 87, right? So we'll call it 37 degrees. Okay. Now the interesting thing and what's cool about this is that you should see the same angle because we are talking about the same angle, right? So if I put in the 0.8 from the trig ratio for cosine, I should still see the same answer. So it's still in my -1. So I'm going to click cosine -1, 37, same number. Okay, so that's how that works. All three of those trig ratios will give you the same angle because we're talking about the same angle. Okay. The ratio gives you the proportionality of the side lengths. Okay. So we're going to go down here now to these bottom questions, and we're going to take a look. Okay. So it looks like they've labeled this triangle. This is going to be triangle X, Y, Z. Okay. So where they've labeled angle Z, this is going to be angle X, and this is going to be angle Y. And then they labeled accordingly. Okay. Now, what's interesting about this question, okay, and this is my opportunity to review Pythagorean Theorem. In the event, you want to do whatever's easiest, right? So when you see a 90-degree triangle, okay, your first thought should be, okay, Pythagorean Theorem is pretty easy. That's this equation that's sitting here, and you should have done that by now, for sure. Okay. That simply states that if I add up or sum the squares of the two side lengths that I have, it should give me the third, where the third is the longest one. So in this case, the hypotenuse. Okay, so in any event that you want to use, like you see that you have two side lengths and you want to find the third, you're going to want to use Pythagorean Theorem. Okay, that's the easier of the two. That's not to say that you can't work your way around the triangle to figure out the side length using trig ratios if you were providing an angle. Okay, but in this particular question, you're going to want to use Pythagorean Theorem because you don't have an angle. Okay, you'd have to first figure out an angle. Okay, like let's say you wanted to figure out angle X, and then you'd have to use that angle to, so you'd want to say, okay, opposite over adjacent, right? So you'd want to say tan X over, tan of, oh yeah, I was right, is equal to 8 over 5. You'd have to get a number, find angle X, and then you still don't have side length Y, which is what you're after. So then you'd have to do it again, except this time you'd have to go like sine X is equal to 8 over Y, and then you could solve for Y. It's way more work, right? Whereas you could just do this right from the beginning. Okay, so that's what we're going to do. Okay, I'm going to get rid of all this. You want to do the least amount of work possible, right? So what you want to do here is solve for y. And so this is what we call the hypotenuse, right? Because it's the biggest one. It's opposite the 90 degree. Okay, so what you're going to do, you've got a squared plus b squared is equal to c squared. This is Pythagorean Theorem. Can only be used with this 90 degree that's sitting in the corner. Cannot use this for anything else. Okay, only 90 degree triangles. So 5 squared plus 8 squared should equal c squared. 25 plus 64 is equal to c squared. Okay, so then we're going to get 89 is equal to c squared. And then what you have to do is just get c by itself. And so c is equal to the square root of 89. Okay, and so then you could say c or y, whatever it is you want to solve for, or the variable doesn't matter too much. Just to keep it straight, we'll say it's y. So y is 9.4 centimeters. Okay, and to figure that out, you just go to your calculator and go 89 square rooted. Okay, now this question says solve. Okay, and I got a little bit ahead of myself here with the Pythagorean theorem. Okay, but solve means, when you see the word solve, it means all side lengths, all angles. Okay, you're doing all the work. Okay, but so now you can fill this in because you know what it is. It's 9.4. Okay, now I'm going to erase some stuff here because it's getting a bit messy. What you can do is I'm going to label this. We already labeled this as the hypotenuse, right? So we know that that's the hypotenuse. And you can put a little box around it like I did in the last question. You can stand in either of these two corners, actually. It doesn't matter. I know this one has it labeled, but it doesn't matter which one you pick as your reference angle. What matters is how you label your triangle. So if I choose, I'm going to pick X just because I know most of you are thinking about Z, right? And if you did pick Z, then this would be opposite, but I'm not going to do that, right? I'm going to pick angle X as my reference, and this is going to be opposite. So opposite is 8 centimeters, and then that must mean that the adjacent is 5. Okay, now I want to solve for angle X. So I'm going to pick, you could pick either or all, any of your 3 trig ratios to get the answer here. Okay, problem is I solved for this one. What if I did this wrong? If I use the hypotenuse in my calculations and this is wrong, then my next number is going to be wrong when I do the work. So I want to avoid using this if I can. If you can't, then you can't. Okay, so what I'm going to do here is I'm going to choose to use opposite and adjacent. Okay, and so that sounds like, if I were to rewrite, so toa, opposite and adjacent sounds like tangent. Okay, so I'm going to go do the work here for angle X. So tan X is going to equal 8 divided by 5. Okay, opposite over adjacent. Okay, then you can go to your calculator and go, okay, what's 8 divided by 5? 1.6. Okay, and then you can go tan inverse of 1.6 will equal X. So X will equal, we can go shift, so 1.6 is still sitting there, and go hit tangent of 58 degrees. Okay, now there's one more little thing that we can do here, and this is a little trick. Okay, you can, if you'd like to, again, we're all about doing the least amount of work possible because this can get tedious when you do 10, 15 of these questions. Again, you could come over here now and use angle Z to solve for angle Z as your reference. Okay, hypotenuse is not going to change, but this would become your adjacent instead this time, and this would be your opposite. These two would flip positions. Okay, now you could do that, do the exact same work, or you could remember the little tidbit of information that says the angles of a triangle must add to 180 degrees, right? Oops. Okay, 180 degrees. And so I now know two of them. I know 90 and I know the 58. So if I go 180, subtract 90, subtract 58, that's going to equal angle Z. And so angle Z is equal to, go to our calculator, 180 minus 90 minus 58, 32 degrees. Okay, that's what it means to solve the triangle. You solved for the hypotenuse, you solved for angle X, and you solved for angle Z. Okay, so if it says solve for a triangle, you better have 6 numbers on that triangle. Right? 3 angles and 3 side lengths. Okay, now, last question, and then you guys will be good to go. A little bit trickier because what you notice this time is I'm not given two side lengths, right? I'm actually provided 2 unknown side lengths this time. So we can't use Pythagorean Theorem in this question because I don't know. Well, we can't use Pythagorean Theorem right off the bat because I don't know the side length. Okay. Now you can choose to do this in any way you want. If you love using the trig ratios, you can use trig ratios to do this whole question. It's a little bit more labor intensive though. Okay. Or tedious. You can use a mixture of Pythagorean theorem and trig ratios and your 180 degree rule that I just showed you above, right? You might just have to do them in different orders. Okay, that's, you got to assess the triangle, right? So with this particular triangle, I cannot use Pythagorean theorem off the bat because I don't have 2 side lengths. Okay, I have 1. I have the 20, right? So you're stuck a little bit, okay? So what you're going to have to do is use the other piece of information that they gave you, the angle, okay? And so let's do that then, okay? So obviously if I'm going to use the angle, that's going to be my angle of reference, okay? And so I'm going to label this, I'm going to go across, and this is going to be opposite, and this is going to be adjacent, right? And I know that that's the case because the 90, opposite of the 90 is always going to be the hypotenuse, okay? So let me erase these because they get messy. Okay, so let's go ahead, and if you wanted to actually, before we go any further, let's do something easy. We can figure out what angle Y is. Angle Y is 180 minus 90 minus 38. That knocks off one of the 3 things we have to solve for, right? You can see the 3 things we have to solve for: X, Y, and Z. Okay, well, I'm going to knock off one of them right now by solving. Okay, or just doing my 180 rule. So angle Y is 180 minus 90, right? It should be 90 minus 38 is 52 degrees. Okay, so angle Y, 52 degrees. Okay, now let's do the next thing. Next thing would be, let's solve for one of the 2 side lengths. So I said, I'm using this as my reference, 38. So I'm going to go opposite, okay? This time, if I were to use tangent of 38, tangent is always opposite over adjacent. That's useless to me because opposite and adjacent, I don't know what they are. Those are the two things I'm trying to solve for. I can no ways, like I can't solve for anything here if I use tangent. But that's why I have two other trig ratios in addition to tangent. Because I can choose either of cosine or sine, right? Because both of them involve the hypotenuse, which I know. So what you can do is go, okay, well, I'm going to pick cosine of 38 is equal to adjacent over hypotenuse, right? That comes from SOHCAHTOA, adjacent over hypotenuse. Okay, and then so you're just going to fill in the numbers. I don't know what adjacent is. That's what I'm trying to solve for. So it's going to be x over 20. Okay, so this is just a little system of equations now, right? So what you can do is, I'm going to rewrite this line here so you can see how to solve it. Cos of 38 is equal to x over 20. Well, what's to stop me from multiplying both sides by 20? Then the 20s cancel on this side, and the only thing left is x. And so x is equal to 20 multiplied by the cosine of 38. Okay, you can type this in your calculator now. Now I have to go back. See, these are still minuses. You gotta be careful. Hit the shift, go back to the regular ones. So what I'm gonna do here, I'm gonna go 38 cosine gives me 0.78. Okay, that takes care of. I'm gonna rewrite this line here. Okay, and so x is equal to that number multiplied by 20. So x is equal to 15.76 centimeters. There are units, okay? And so just to clarify, cosine of 38, when you type that into your calculator, you will get this number out. Okay, that did the math there. Okay, so almost done. X I now know is 15.76. Now there's one more thing you can do, and I'm going to do it in a particular way. You can just pick another trig ratio, in this case something that involves opposite, and you could say, okay, well, I'm going to pick sine because sine is opposite over hypotenuse, and I'm going to do the exact same work. Okay. What I'm going to show you is that you can actually use Pythagorean Theorem because now you know two side lengths. And so what you can do is go a squared plus b squared is equal to c squared. But here's the catch this time, okay? C squared always has to be the hypotenuse, always. Okay, so what you're going to have to do here is it's going to equal 20 squared, okay? And then these two here don't matter. So you could go a squared plus 15.76 squared, right? That's the other side length that I plugged in. Okay, and so a squared, 15.76, we can say squared, it's 248.4, we'll call it. Oops. Oh, we gotta type in what 20 squared is. Let's type in 20 squared. 400. Okay, so a squared, here's the catch here. This you can move over, but when you do that, it has to become minus. Okay, so a squared is going to equal 400 minus 248.4. A squared is going to equal 400 minus 280. Oops. 400 minus 248.4. 151.6. Okay, and then square root both sides. A is equal to square root of that, 12.3. That's you done. There's one of your answers. There's answer 1, there's answer 2, there's answer 3. Okay, that's you solved the triangles. Okay, you can see how these can get a bit laborious and tedious if you're always going to use one particular method. Okay, I would encourage you to use a mixture of the 3 methods that I showed you today, or the 3 kind of tricks. This would be 1, use your 180 rule, use some primary trig ratios, and use Pythagorean theorem when you can. Okay, so that's it. You've got a few questions here, and I want you to find the angles indicated on the triangles in these questions. Okay, so that's it. Let me know if you have any questions.